Hello and welcome back to another video. You will see I am in the Apprentice 1-to-1 Academy, or those of you who've been watching the earlier videos will know that to be the case. We're at the side of the roller doors here leading to outside, and we're going to install an EV charge point today. You'll see the guys Matty and Nathan have pulled a cable over already back to the distribution board. I'm going to show you the wiring up of each end, explain the setup we're selecting to use in this case, and there's a couple of reasons why we're going to go down those roads, but we'll talk about that as we're doing it. And yeah, we're going to get on with it. I've got my setup all ready to go. Got the Milwaukee pack out here with all the drawers and all my stuff inside it. I've got a little workbench set up here with the tools all out and ready to go. I'm going to bring you in a bit closer and we're going to run through the install from start to finish. So let's get straight to it. Okay, so we're going to use a rotary isolator. So we've got a point to turn off the EV charge point from inside. I'm going to mount that up just at the side of this tray work here. This one's from Europa. It's just what was on the shelf at the wholesalers. I've gone for 63 amp just because it's got more room inside it. Those of you who wire these quite regularly will know if you go for the 32 and 40 amp versions, they're not quite as roomy and you're making life a little bit harder for yourself than you necessarily need to. It's not a great deal of extra cost, so I always prefer to go a little bit bigger if possible. So we'll get on with this now. I'm going to open it up, start putting it on the wall, and I'll show you the process for doing that right now. So point of note with these, you'll see inside there, if I get it in close up, there is an up arrow. The amount of times I've fitted these the wrong way around, when you put them down, I've been taking the front cover off, you pick it up and put it on the wall and mark it, put it back down again, drill your holes. It's so easy at the last stage to just screw it to the wall the wrong way around. You then put all your cable entry points in, and if they're not in the right side, when you spin it around the right way later on, you can have wasted the component. So make sure you're checking that. If you're not used to installing a lot of these and you're an apprentice, following on, you can see there's an up arrow in there. So we're going to get this marked up now. See, basically you've got the holes that are going to screw straight through these outer edges here, and that's so the internals of this can remain watertight if you was to install this outside. The IP rating on it, if I find the box, should tell us on here. So this is an IP65 version, so it is suitable for use outside, but obviously we're in an inside environment here anyway. Again, if you were ever outside using these and you are glanded into them, I would always say coming from the bottom. If you're using a waterproof gland and seal, it's very unlikely that they would ever leak, but you can remove that from being a possibility just by entering from underneath, so any water that runs down the cables or onto them isn't going to find its way into this. But yeah, let's get this on the wall. So hopefully you can see on there I've got the Klein tools level on. That's the digital level. I'm just going to line this up now, get it marked with this. So you see, I just used the Klein tools digital angle gauge to get my level over there. It's a really easy and accurate way to know that you're going to get that spot on. I also used the Marksman chalk. I put some glasses on. I wasn't expecting it would squirt in my eye, and I don't think it would cause a great deal of damage if it did, but better safe than sorry. We can get some more PP on now, drill these holes that are marked on the wall, and we'll zoom back on with this in just a sec. We've got that bang on level, which is fantastic, so we're nice and secured back to the wall. We can start glanding our cable into it, and I'll get on with that now and show you how we approach forming the bend leading up to that isolator and making sure we're going to gland it in right. So coming over to you, we've got that 6mm 5-core cable, and if we look on our gland chart for this particular gland, a 6mm with the 5 cores is a 20mm gland. You can see there, now we're in focus. So first up is to get the gland mounted onto the actual isolator, so we'll do that now. So one of the things electricians have to do lots of is making holes in things, and you will have seen me there with the DeWalt 18-volt combi drill and the Armeg hole cutters doing just that on this isolator. So we popped a 20mm hole in there, and we're now going to attach the gland into that plastic enclosure. There is loads of techniques for how you strip steel wire armour cable. I've demonstrated absolutely loads of them, from using hacksaws and knives to some of the more modern and fancy stripping tools. You can use the cable tie trick to get your distance between where the gland is and marking around where you're going to cut the armourings off. I usually put a bit of tape around to give it a good marking. In this case, I've used the Knipex stripping tool, and it's given a really clean cut on all of those armours, and you can see I'm removing them right there. So having used the Knipex Ergo strip just to open up the inner bedding on the steel wire armour cable, I then popped it through the gland. With that still on the end, it just makes it a bit easier to keep the cores together. And just finger tightening this up for the minute, and then we'll nip it up with a spanner. When you're tightening into plastic, you don't often need both sets of grips because it tends to grab in quite nicely with the nut anyway. But make sure whatever you're doing, it's nice and tight, and don't forget the banjo. And now we're all in and the gland's nice and tight, we can remove that outer bedding, give it a little rub down to get rid of the chalk on the inner cores, spread them apart, and we're ready to go on to the next stage. Okay, you'll see we've got all the cables in now. I've got the fly lead attached with a brass nut and bolt. I've gone for nuts out on this one, so the nuts underneath, I'll take you up to have a closer look at that once we finish wiring it all in. You could, if you want, put the nut inside and have the stud sticking up. I always prefer to get nuts out where you can. I think I've said before on other videos with your containment, especially when you've got cables inside, getting rid of any earthy snaggy bits is always a good move. And that's tucked up around the back of this gland now. And when we put the outgoing cable on, we can also use the same nut and bolt to then put our gland on to that as well, to give us the earth onto the armouring. So it kind of doubles up. With the one hole for the banjo, it'll make sense when we put the other cable in. That's why I put it where I have. Okay, so there's the isolator on the wall. You can see we've got our cables dressed in. They're looped up quite nicely into the top. So your input's denoted with an L1, L2 and L3, and then on the output, if you can see that, it's got a T1, T2 and T3, just to denote which is in and out. Our outgoing cables have got plenty of space to be dressed in. I've left loads of room. That's the purpose of going for a slightly bigger isolator than you might need in terms of its rating. But we've got that now. We've got the banjo on with the nut in the back there. You can see I have ferruled in the earth. I don't know if that's showing on camera, but it is ferruled up in there. And we've got the nut on the bottom. And as I say, when we come to put our outgoing circuit on, we can use that nut and banjo connection point with a fly lead to earth the armourings on that. You can see that's our lead running up and away into the distance. We can pop a little cleat or two on this cable here just to secure it a bit nicer onto the wall. But that's our isolator done now for the charge point. Now eventually that's going to live outside, so it's going to live just through this wall here. We're not quite ready to do that yet. It is going to be an ICS 3-phase charge point, but we're just going to do this circuit for now, so it's all ready to go. Got our isolator done. We're going to zoom over to the other side, connect into the Proteus board, and I'll show you the benefits of that system in just a second. So this time I've gone for the Knipex knife to remove the outer insulation. It's the one with the hooked end, so it'll slide in nice and safely down the back of the insulation to remove it, and then the same process to remove the armours. So I've used the Nipex slice again, got them all in one bundle and removed them away there. I did forget to put the shroud on first, so put a bit of tape around the end there, slide it over the top, and with a shroud you want them nice and tight so the friction holds it in place. That's when you know you've got it spot on, and you can drop the nut in there as well and it'll hold it in position while you carry on with the rest of the process. So with this one we had an adjacent steel wire armour as well, and I'm just setting this up so we can get the hole for the banjos in the same position and thus use one nut and fly lead to earth those down. You can see I've cut that out with the DeWalt combi drill, and now I am opening up the hole for the entry point for the armour itself. Using the arm egg hole saw again, and we're into position. We can get that nut in place on top of the banjo, again the brass nut and washer, and we're good to go with the rest of the process. So this is amazing from Klein, you will have seen me using it on there. This is the metric version. It's got a range of sizes, I think from 15mm all the way down to 6mm, and luckily the brass nuts and bolts are 10mm on there, so this is absolutely ideal to make sure that's nice and tight. I can finish off landing this now, and then we'll see where we're up to in just a sec. So again, repeating the process that you would have seen over on the isolator, except for this time we're going direct into the top of the distribution board. So we've got the armours nicely cut, and they can drop straight over the top of that gland body to be tightened down into position. This Proteus board is absolutely amazing. For those of you who are working in the EV sector especially, the way these can be configured is off the charts. It really is. You can have all kinds of variations set up. Lots of it is off the shelf through CEF. You can also get some very bespoke and custom built versions to suit whatever environment you're installing within. In this case, I've set it up to be our main distribution board within the Apprentice 1-to-1 Academy, mainly because it's got a couple of those RCDs there to cover the three-phase circuits that we might have learners working on. Still got lots of circuits to rewire in and around this place, but we're slowly but surely getting there. And you can see we've got the RCD ready at the top there to dress this EV charge point into. As always, these terminations will be torqued down later on, and you can see we've got everything dressed away into that board now. Still need to tidy up the steel wire armours dropping down to it, but we'll get to that in just a minute. So I've gone and found some proper electricians to help install the EV charge point, and Matt is going to demonstrate this for us. It's the ICS 22 kilowatt, and he's just marking out the holes for the mounting plate itself. These are really straightforward to install, and we'll show you why as we move through this video. So Matty's drilled out the holes for this mounting plate and then fixed it back to the wall, and you can see now he's opening up the Jubilee clip style clamp on the back of these charge points. So these are a different kind of glanding arrangement to what you might be used to, and we've showed it before on the channel. In this case we're entering into the charge point with some MYY cable, so that's your solid core cable with a tough outer sheath, but it doesn't have any armourings. They are quite difficult to dress away, these kind of cables, if you've not worked with them before. The fact that they're solid, their bending radius is not quite as good as you might find with some of the flexible based conductors, but he's got it in there. You'll see he's taken the approach of dressing in the L1, L2 and L3 first up, leaving the neutral and the CPC a little bit longer. So he's taking the outer insulation into that Jubilee clip that we mentioned, so it's going to be able to clamp onto that and hold it into position, offering some strain relief, and he's tightening up his terminations now into this base plate. Now on the base plate itself there's some diagrams which will show the kinds of connections you can make based on the earthing arrangement. It is different for TN, TT, your 3-phase and single-phase connections. It's all there on the plate in front of you, which makes wiring it really simple. You can see Matty's bent over the CPC to the other side of the connection plate, and he's terminating that in there nicely, so we've got the wiring neatly dressed away inside this mounting box. So he's just got his neutral left to do there, so he's going to shape that away, cut off the excess and pop it straight into the terminal. So you'll see Matty's made a good job of dressing all of this away into the charge point terminations. There isn't a great deal of wiring room, especially when you're using those solid core cables. As I mentioned earlier in the video, selecting a larger size isolator is a great plus point in terms of wiring space. But when you're working with these EV charge points, it is what it is. That's the yellow Jubilee clip you can see there that clamps down onto the outer sheathing to hold the cable inside and offer some strain relief. Matty's just popping in the CT clamp connection cable, so that's all in position, and then we can drop the charge point front cover on. The thing I like about these is you can get blanking plates to sit over the front, so if you want to pre-install a lot of these before the customer's ready to add the charge points into their car parking areas, it gives you the flexibility to do that. And equally, if there's any maintenance or repair work that's needed, the module simply slides off the front and a new one can be dropped into position. As Matty's going to demonstrate here in just a second, just like that, you can see he's dropped the front cover on, and then there's the securing screw for underneath, which fastens the unit into position so it can be removed by people using a standard screwdriver. Now he's moving on to the isolator, and as you'll see again, it's the NYY cable. And he's going to struggle a bit more than I did with this. Obviously the steel wire armour is 7 strands, so it's a bit more flexible. You can shape your conductors nicely, but I tried to leave him as much wiring room as possible, so he's got a fighting chance of getting these into the bottom of the isolator. And again, I made the mistake earlier on in the video of talking about the steel wire armour gland and the connection of the banjo and using the same hole for it, which was a nonsense because we've gone for the MYY cable here with a plastic stuffing gland. So it was never going to be a probability, and that was just me getting carried away with myself. And Matty's now dressing this away, tightening up the stuffing gland so it's holding that cable into position, taking his neutral over first to the furthest point on the isolator and dressing that up and away nice and snug into position. So just the CPC to go, and you can see he's stripped the end of it ready. It's going to drop into the bottom entry hole over at this corner and straight up underneath the cables coming in from the top. Dressed all of his conductors away to the left hand side of this isolator. You'll see it is a bit of a struggle again because of the solid core cabling, just giving them a bit of persuasion into position, and then we know we've got that nicely formed bending radius of all the conductors inside this isolator.
Just, do you want to just cleat this? See if there's any linear clips or cleats that fit.
Okay, so you can see we've got the TIS test set down there. Just been running through the range of tests to make sure that this is all good. It seems to be working just fine. I've left the little test adapter in there, so the EV100. We'll have a little look at that a bit closer and run through this ICS tester as well. Okay, so with the EV100, it's a really simple way of running through the test process. You've got to portion your leads to the right terminals, run through the sequence on the screen. I've shown it lots on the channel before. This video is already going to be quite long, so I don't want to include it this time, but if you want to go off and watch it, I think it was on some pod points and a Zappy further back in the channel. So if you want to see some testing of a three-phase charge point, it's all on there. Just a quick scan through this. If you was wanting to introduce a fault to the charger, you can swing it into fault mode, and you can see here it's detected that within the charger itself and turned off the power leading out to the lead. It's now asking us to remove the charging plug, so we can do that, pop that away, and it's now reset itself. So if we plug the charger back in, turn it back, okay, so you can see I've reset that now. We've gone back to a normal state. If I swing it over to an air fault, you can see it's disconnected as well. It's detected that internal to the charge point and turned the power off accordingly, asking us to remove the plug. Again, if we swing the plug back out, put it back into a status mode that is now okay, stick it back in the charger. It's not going to do anything until we swipe this RIFID card against it, or there's the little QR code on there that you can scan. These have 4G built-in wireless connection, so we can connect it into our internet here. We can take payments if we wanted to, people coming along using the charge points through some of the OCP technology, so you can register with one of the payment providers, or you can just use it for free. Well, it's not for free, is it? Someone's paying the bill, but you know what I mean. And you can see there we've got the adapter on now again, power on all three phases, fully tested off, which is fantastic. Okay, so I'm pretty happy with how that's come out. We've got the charge point up on the inside. Eventually we will move it outside, but for the minute it was nice to have it in here as a working example of a charge point for someone to come and work in and do some testing with, where they're not out in the rain. Our electric vehicles haven't arrived yet, as you all know, so as soon as they do, we'll swing this through the wall and to the outside, and that's why this isolator comes in really handy. So if we're wanting to lock the power off, even if it's not for maintenance and for a security purpose, so someone can't pull up and try and hack into these things or whatever and get a free charge, I'm sure it's not going to happen. But you've got that mechanical control as well, so if you want to lock it off so no one else can use it, then you can do so. Equally, there's the aspect of maintenance as well. So of course, just the other side of here, we've got the 4-pole RCD that we could lock off to give us the isolation that we would need, but it's much easier to have that local to the charge point, just so you can turn the power off, put a lock on, and know that you are safe inside this to do any work that's necessary. Again, that's why we've gone for the 4-pole variant in this case. So I hope you've enjoyed watching this video installing the ICS charge point. Let the guys crack on with it. Got some proper electricians instead of somebody ham-fisted like me. They've made a great job of it. We've gone for the NYY cable running out from this isolator. So all my waffle about using another banjo on that nut within this isolator was a total waste of time, because we weren't using steel wire arm leading out into it. And the reason for that is the clamp inside this with a little yellow thumb wheel actually would bypass the pen vault protection in this charge point. I've made that mistake in the past before, assuming that it needed to be clamped down onto the armourings of a steel wire armour cable, but it's not the case. So don't make the same mistake as me. Get in touch with the ICS tech support team and they can give you all the right information around that as well. Again, running back through the tools that I've used, obviously there's a load from Klein tools in this one, all of the screwdrivers, the laser level, that socket fastening screwdriver, which is absolutely fantastic. All bought by me. Klein do sponsor the Apprentice 1-to-1 Academy, so keep that in mind. on your judgments around anything that I say to you, but I've used that gear now for a long time, years and years. It's absolutely fantastic. Same with the TIS MFT Pro and the EV100. I bought that and it is amazing. It's been worth its weight in gold the last couple of years with all the EV charge point testing we've been doing. And the Proteus distribution boards, again, supporters of Apprentice 1-to-1, just like TIS and Klein. But we bought that, we paid for it with the hard-earned money. It is a great solution to a problem we all face. And hopefully there'll be some content coming out on the channel soon from a factory tour of Proteus, where I've been to see how those industrial boards are all put together and made. There's such a wide range of those boards. If you're installing EVs into any sort of scenario, be it a big feeder pillar or a simple little installation like we've got here, Proteus are going to have you covered, and it is really affordable as well. So go check it out. There'll be links in the description for all of that stuff for anyone who is interested. If you've got any questions around this video, please do drop them in below. Massive thanks to Matthew and Nathan for helping me with the install. And we've now got an EV charger. It's absolutely fantastic. We've put it inside for now so we can demonstrate it to people. They can come and have a little play around with it. It's in the dry, it's not out in the rain. If the weather's a bit rubbish, it's still a bit naff this time of year. So we thought we'd pop it inside. In the end, we're going to punch it through to the outside when our electric vehicles eventually turn up, hopefully sometime in 2023, but I was saying that in 2022. So it may end up being in here for the foreseeable future yet. Thank you for watching, get involved in the comments, and I'll see you on the next one.